Today we're going to test a couple of consoles. We've got the M7CL, the LS9, we've got the MTX5 and MRX7 processors represented on the screen there and there. We've got the O1V96i, we've got the CL, we've got the QL, the TF, the DM3, and for fun, the Mackie 1402, the Behringer X32, the Allen & Heath Avantis, and the Digico Quantum 225. So the first thing I'm going to do is calibrate the output levels of the consoles. So the internal oscillators on all the consoles, except for the Mackie because it doesn't have one, have been set to -10 at 1 kilohertz. Now, the thing is the Avantis metering is a little bit different, and so on this console, 11 is what matched everything else closest. Also, they don't let you choose 1 kilohertz exactly. It's like 1.03 is the closest. So just a note about my setup, because we have analog consoles and varying digital formats, I just went ahead and ran all the analog outs into a Yamaha Rio. Luckily the Rio is a very high-end piece. All of the preamps are so similar to each other, I've already tested them, they cancel out to basically silence. So whatever little coloration they may be adding, at least it's the same across all of the inputs, and so that's what matters for our test. By the way, we have a TO in the mix here as well, and the Rio itself is one of the test devices. So just to be fair, I did run the Rio out of itself into an input and then back out again into another input, so it has the same topology as the rest of the setup. Now all of the Rio inputs are set to 0 dB, except the one that's accepting its own input again. So let's take a look at the oscilloscope output from the M7, LS9, MTX5, MRX7, O1V96i, the CL, QL, TF, DM3, X32, Avantis, and Quantum 225. Now I've added corrections for these in the software, so if we roll through the devices again, you can see now that all of their output levels show up as being the same as each other to within 1/10 of a decibel accuracy. Now I've turned off the oscillators on the consoles, and I'm running noise out of Logic now, and it's going out the Rio to all of the console's channel 1 inputs with this gigantic Y-cable system that I've made. And I've gone ahead and checked that it's not decreasing the voltage or there's no distortion or anything like this. I've preset the input and the output faders on all the consoles to be at their 0 mark, and I've also preset a head amp level that seems to be in the ballpark for most of the devices. Now on the 1402 and the ONV96i, because they're analog gains, I just have to kind of guess. I've already time aligned these, so I'm not going to make you sit through that, but if we look at the M7, you can see that with a head amp setting of 26, we're pretty close to the 0 mark on our magnitude graph, and the phase is very, very linear. If I increase the delay by 1 sample at 48 kilohertz here, you can see how much it affects the phase graph. So like we know that that is accurate to within a sample at 48K. Very, very accurate. The LS9 with a head amp setting of 26, also right at 0. Now the MTX5 had a head amp of 30, and it's actually a little bit shy. Not quite a decibel though. Same with the MRX7. The ONV96, I don't know what the head amp is because it's analog, but it's within a decibel. CL was back to 30. Same with the QL and the TF and the DM3. 1402, I don't know what it is, it's analog. X32 was actually 27.5. The Avantis was 31, and the Quantum 225 was 30.5. So I've increased the vertical scale of the magnitude graph to where we're looking at 1/10 of a decibel jumps here. And I've already gone through and added compensations to all these within 1/10 of a decibel. So we can see the M7 here, LS9, MTX5, MRX7, O1V96i, CL, QL, TF, DM3, 1402, X32, Avantis, Quantum 225. Okay, so we're going to get into the null tests between these consoles' preamps, but before we do that, we have to set up some expectations about the results. Like, how much cancellation away from the original signal level is enough to say that any differences between these preamps are so small that they're inaudible or they really don't matter or whatever. Is it -10 dB of cancellation? How about -30 or 50 dB? Like, what's your standard? So I've got these two SM58s here. They're so new, they don't even have any dents in them yet. And if I talk into one of them, check, 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 1, 2, and I talk into the other one, check, 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 1, 2, they're so close, you can't hear a difference. And if you say you do, you're probably lying. Okay, so now I've replaced one of the SM58s with an AKG 451 pencil condenser microphone. So now you should be able to hear a difference. Hey, check, 1, 2. Hey, check, 1, 2. So I've got these two brand new SM58s next to each other in front of this little speaker system, and I'm going to play some noise through it here, and let's see how similar they are. Obviously, they are very, very similar, but if we flip one of them out of polarity and combine them together and run this test again, so we can see the cancellation here, and at 400 hertz, we've got like minus 40, about minus 50 dB. This is approaching some of the deepest cancellations that I've seen in real-world tests between two identical things. I mean, these 58s, for all practical purposes, are identical. You can't hear the difference between them. So the phase does shift a little bit in the higher and lower frequency ranges, and that's why the null isn't perfect, but we're still getting like minus 10, minus 20 dB. So maybe it's safe to say that like, if something is between minus 10 and minus 20, somewhere in here, you know, we're talking about impractical differences, whereas if something is like minus 40, we're talking imperceptible differences. So now I've replaced one of the SM58s with the 451, and let's run the same test. So you can see that the frequency response is still pretty flat. I mean, it's within a decibel or two, except for the very high frequency and the very low frequency, where a condenser mic is just more sensitive. And the phase response drifts a little bit at the extremes as well, but is still kind of close to zero during the mid-range. Let's see how well they null each other. So in this null response, we can see that things don't even approach the minus 10 dB mark, except for in a few spots, but below 100 hertz and above 10,000 hertz, it doesn't null, it actually combines. It sums together because of the incredible phase shift and the amplitudinal discrepancy. So I think it's fair to say that if something isn't even approaching the minus 10 dB mark overall, it is definitely different in a perceptible and practical way than the thing it's being compared against. Okay, so let's begin with the M7, and we'll compare it to the LS9. We'll flip that out of polarity. So we can see a very, very deep cancellation, below minus 50 for a lot of this content here in the mid and upper high frequency. The slope upwards in the low frequency, I've come to believe, is actually due to slight differences in the roll-off at the very, very low end of the spectrum, which creates a bit of a magnitudinal difference and ruins the null, because the null rests on a knife's edge. The amplitudes of the two frequencies at any point have to be so close. You know, these preamps are probably the same, but the one console just decided to have a slightly different high-pass filter setting. Here's the M7 and the MTX5. Let's flip the MTX5 out of polarity. So you can see a very, very deep null here again. Minus 50 at 100 hertz. Now, I've found that the upward slope in this case a lot of times is just differences in time arrival from the A to D and D to A converters, and it's even less than a sample length. So for example, if I go here to the MTX5 and I increase the delay by 1 sample, you can see that we really kind of ruin our null. It's very, very easy. Here's another sample. Like, it's really easy to ruin this thing. It rests on a knife's edge, and the problem is that, you know, if we go back to the M7 here and we add one more here, yeah, see, we're starting to, you know, 1 or 2 samples difference really gets away from a perfect null, and to me, because it affects the high frequencies the most, it seems like what we're really dealing with here is either slight time arrival differences that are even less than a sample length, or we're just dealing with slight phase shift differences in phase between the two that, you know, don't really amount to a tonal difference so much as just, you know, slightly different phase, and if it's even off by a little bit, you don't get perfect cancellation. But that's why it's so even in its slope. Okay, so I should probably make this theory a little more concrete before moving forward because you're going to see this issue come up a lot. So this is 3 kilohertz, and you can see on the oscilloscope the yellow is the reference trace. Now it's going to move side to side because I'm not triggering it. It just looks smoother for this demonstration. If I play sound through the M7, you can see that it's almost right in time. It's slightly ahead, actually, just a teeny bit. The problem is that at 48 kilohertz sample rate, if I try to, let's say, delay the M7 by one more sample, the jump is huge, right? So like if I go forward in front of the reference by one sample, you know, like this right here is the best that I can do, and it's close enough. It's really, really close. But look at the MTX5. It's slightly behind, and again, like if I try to bring that forward by one sample, which is the best I can do, I've overshot the yellow by more than it was delayed. So like this is really all I get. And if I wanted to be more accurate, I'd have to have a much higher sample rate, I suppose, like 96 or 192. But my equipment here is limited to 48 for a lot of different reasons. And I do think that this is just a global delay issue because if you look at a higher frequency, like let's look at 6 kilohertz, again, the gap has stayed the same. Now, the thing is, because we have a higher frequency, even though the amount of time delay has stayed the same, it's going to be a higher proportion of the phase angle. So it's more negative phase shift at this frequency than it was at 3 kilohertz, which again, because the M7 is still pretty much right in time, it's going to cancel much less at 6 kilohertz than it did at 3 kilohertz. There's no misshapen waveform or anything, and you can see this even if we go up to 12,000 hertz. So again, the time delay has stayed the same. There's only 4 samples for the entire waveform at 12 kilohertz. This is why you see all these like weird peaks and stuff. But there's no other misshapen parts of it, no other harmonics that we can see. There's the M7. And so this is, again, what I think is going on is just there's slight time arrival differences that don't seem to be fixed if I, for example, go Dante all the way through to my oscilloscope once I've hit the preamp. It doesn't seem to fix it if I word clock the consoles. So I don't really know why there's a slight time delay. Now bear with me here. I've set up a secondary test environment to test another principle which might explain some of the graphs we're seeing, and that is even if the consoles are arriving perfectly in time, there could be slight magnitudinal or phase differences which explain some of the responses we'll be getting. So here's channel 1 of the Rio, and here is channel 2 of the Rio compared against the reference, and you can see that they have an extremely flat magnitude and phase response. The magnitude graph is at 1 decibel increments, very sensitive. Now, if we add an EQ to this second channel that has a low shelf at 20 hertz and below, that is only minus 0.1 decibels, I mean basically nothing, and we add a high shelf at 20 kilohertz and above, which is at minus 0.5 dB. Again, basically nothing. It barely registers on the magnitude graph, and it has almost no effect on the phase graph. But let's see how this affects our nulling. Okay, so here's channel 1, and let's add in channel 2 in phase. You can see that it increases by 6 decibels. Now, let's take channel 2 and let's flip it out of phase and see what happens. Okay, so we have a very, very deep null, below minus 60 dB, almost at all frequencies here. The spread in the high frequency is just due to the density and the imprecision given that it's such a low signal. Now let's go ahead and add our EQ to the second channel and see what happens. Now look at this V shape. We have an almost 30 decibel loss in the null effect at the high frequencies, and we have a 20 decibel loss in the low frequencies. And again, all of this was caused by just adding this tiny, tiny bit of roll-off at the extremes of the frequency range. Now let's compare the MTX5 to the MRX7. Now obviously these preamps are probably the same. So here's the M7 and the O1B96. And here is the MTX5 and the O1B96. So there are some differences, I would say, in the preamps here, but like they're very low, minus 30 dB. That's very, very low. Here's the M7 and the Rio preamp. Here's the M7 and CL. I am assuming that this is going to be true with most of these other devices here. Now, if we compare the CL against other things like the Rio, CL compared to QL, to me, this means that the onboard CL and QL pre's are probably the same pre's. Here's the CL and the TO, probably not the same preamp, but, you know, the differences are minus 30, minus 40, very, very low. There's the TF. So interestingly, probably the TO and the TF have the same preamps. So if we jump over there and look at the TO and the TF together, yeah, we can see most likely they're the same preamps. Here's the CL and the DM3. Here's the DM3 against the QL and TO, TF, DM3 against O1V96, MRX, MTX series, and then the M7 LS9. There's the Rio against the TO. Let's compare the M7 against the non-Yamaha products. Here's the 1402. And here is the X32. Here's the Avantis. And here's the Quantum. Now let's compare the CL against all of these same products. CL Quantum, CL Avantis, CL X32, and CL 1402. Let's compare the DM3 against 1402, against X32, against Avantis, and against the Quantum 225. Here's the 1402 compared with the X32 and the Avantis and the Quantum 225. X32 versus Avantis and Quantum 225. And then, of course, Avantis and Quantum 225. I've got a little kick and snare loop going on here, and let's just run it through the different consoles. Again, no processing on any of the consoles, just in and through. If there are differences between these preamps, this is high quality audio. You can go listen to it on your studio headphones or monitors and have at it. Okay, so here's the M7 with this loop, and I'm going to null it against the LS9, which almost certainly has the same preamps. Here's the MTX5 and the MRX7. Here's the M7 and the MTX5. M7 and O1V96. M7 and CL. M7 DM3. M7 1402. M7X32. M7 Avantis. M7 Quantum 225. Here's the QL and the O1V96. QL and CL. QL and TF. QL DM3. QL 1402. QL X32. QL Avantis. QL Quantum 225. Here's the DM3, 1402, DM3 X32, DM3 Avantis, DM3 Quantum 225. All right, so on the DM3, I've got the compressor going, and I've got similar compression settings on all the rest of the consoles. Infinity to 1 ratio, 5 millisecond attack, 50 millisecond release, or close to 50 milliseconds. Soft knee, no output gain. And then the threshold I set to where with a 1 kilohertz tone, they're all compressing the signal the same amount. So the thresholds vary by a decibel or so per console, but not that much. The reason it's 50 milliseconds release is because the Avantis won't go any lower than 50. So we're going to match all the rest of the consoles to it. So let's hear from the M7 first. LS9. MTX5. MRX7. O1V96. CL. QL. TF. DM3. X32. Avantis. Quantum 225. So again, obviously we can hear that if we null the M7 and the LS9, it's almost certainly the case that they have the same compressors. This is also true of the MTX5 and the MRX7, probably just the same processing. Here's the CL and the QL. Here's the CL and the TF. CL DM3. Now here's the DM3 and the TF. Here's the DM3 and the O1V96. DM3 and the MRX7. DM3 and the M7. So here's the M7 and the X32. So they don't cancel each other all that well, so there's probably some differences in how they work. M7 and Avantis. Here's the M7CL and the Quantum 225. Here's the X32 and the Avantis. And the X32 and the Quantum 225. And then, of course, here's the Avantis and the Quantum 225. Now, a lot of times where the differences in compressors really show up is when you take the attack and go down to almost nothing, like 0. So let's go ahead and do that on all the consoles. And let's also change the knee to hard. Beginning with the M7. LS9. MTX5. MRX7. O1V96. CL. QL. TF. DM3. X32. Avantis. Quantum 225. So another way we can look at this is I have a full range tick kind of sound that I can play through the consoles, and you can see it in yellow as the reference trace here. The oscilloscope is set to trigger so that it just keeps it in place even though it's repeating on a loop. If I listen to it through the DM3, okay, we can see that the entire sound is less than 50 milliseconds long. So if I increase the attack to 1, so it lets that first little bit through, and then as I increase the attack all the way up to about 50, we can see that it's letting almost the entire sound through without any real change. Here, if I disengage the compressor, there's still some amount of compression, but it's very little. So on the M7, we can see that if I increase the attack to 1, and then back to 0, LS9, 1, back to 0. So here's the MTX5 at 0, and there's 1, back to 0. MRX7, 0, and then here's 1, 0. O1V96, 0, and then here's 1, and back to 0. CL, 0, there's 1, back to 0. QL, 0, 1, 0. TF, 0, 1, back to 0. DM3, 0, 1, 0. Behringer with apparently a broken screen, 0, 1, 0. Now the Avantis doesn't quite go to 0. It gets super short, like way short, but here's essentially as fast as it will get. There's 1 milliseconds roughly, and there's essentially 0. Now the quantum 225 doesn't go to 0 either, but we can increase it to 1 millisecond. And then back down. Now let's shorten up the release times. The quantum 225 won't go below 10, so we'll set everything else there except the Avantis. You don't get to join the party because you don't go below 50. Let's listen to this. So the X32 will go down to 5, as will the TF. It'll go down to 3.34. It doesn't actually go to 5. The QL, the CL, the O1V, and these will go down to 3, it looks like. They don't go to 5, but then we've got 5 on the LS9, and then we've got M7 is 5. So those will be comparing at 5 milliseconds. The DM3 doesn't go below 8.5, so you don't get to join the party either. So it's interesting, back on the TF and the MTX MRX units, you kind of hear some artifact or something, some harmonics. Now what's interesting is that it goes away as soon as you increase the attack to like 1. This is also true on the TF. Increasing the attack to just like 1 gets rid of that sound. So now we're back to about 50 millisecond release on all of the compressors. Still an attack of 0 or nearly 0, whatever the shortest amount. Hard knee. And I'm playing a single half cycle of 20 hertz. So let's start with the M7, and I'm going to bring the attack slowly up to 10 milliseconds. Skipping the LS9 because it's the same as the M7. Let's do MTX5. I'm going to skip the MRX7D. It's basically the same as the 5. Let's go to the O1V96. Here's the CL. Skipping QL and going to TF. And the DM3. X32. Now the Avantis doesn't start at 0, but we'll go up to about 1 here. Okay. 2, 3. Now the Quantum 225 also doesn't start at 0, but we'll go up to 1, 2. So next, let's play a vocal loop, and I've got the compressors all set to 0 attack or close to 0, about 50 millisecond release, and a hard knee. First, let's listen to it without the compression. And then here's with. Moving to the LS9. Moving to the MTX5. You can hear that distortion adding 1 millisecond of attack really cleans that up. Going to the O1V. Going to the CL. QL. TF. Again, there's that distortion. So on the TF, going to 1 millisecond removes that distortion. Going to the DM3. Again, DM3, 1 millisecond attack. Really cleans that up. Going to the X32. Going to the Avantis. Going to the Quantum. So I have to increase the attack to at least 5 milliseconds in order to get rid of the distortion. Let's go back down though, and also take the release time down. X32. DM3. TF. QL. CL. O1V. MTX5. LS9. M7. I should point out that on the MTX5, even with this very, very fast release time of 3 milliseconds, if I hit it with 1 millisecond of attack, cleans it up. This is also true on the TF. Now on the DM3, it doesn't go below 8.5 release, but if I take the attack to 1, cleans it up. So the next test I'm going to run has to do with EQs. You can see I've made a pretty ridiculous EQ on the M7 here, but all of the bands are supposed to be at plus 15 dB with a Q of 10, and it looks like it's pretty accurate. Now you'll notice between type 1 and type 2 it changes things a little bit in how it looks on the screen, but it doesn't seem to change how the EQ actually functions. Now to save time, I already know that all of the Yamaha EQs, when set to the exact same setting, and when given the option for a legacy setting on the newer consoles, will produce the exact same response, except for the DM3. In the high frequency, it looks like you need just a slightly tighter squelch in order to get the same result. We can look at that here. You can see with the DM3 on just the high band, if I actually do bring it to 10, it widens just ever so slightly from all of the other consoles. So putting it at 12.5 makes it about the same. So on the CL, which is one of those consoles that has the various options for the EQ type, we can see that if we go over to the smooth setting, it responds slightly differently. There's the aggressive. There's the precise. Now on the X32, the gains matched, but the squelch required about a 4.1 on the lower 3 bands, and then the 10 kilohertz band needed a 5.3 squelch in order to match. Here's the Avantis with the 1/9 setting for the squelch, and 15 dB of gain, matches pretty well. And here's the Quantum 225. Looks like it matches very well. Going back to the M7, and we're playing that thumping sound again, we can see the post ringing on the oscilloscope, typical of these types of filters here. If I turn off the EQ, that's just running through the console with no processing, and then with the EQ. Let's quickly run through all of the consoles. So they're pretty much all the same. Now going back to the M7, we can see that in this case, the Type 2 does seem to produce a different sound. It seems to favor things that go in the positive direction. So on the CL, Type 1, type 2. And then we have legacy, smooth, aggressive, and precise. There's the TF. There's the DM3, X32, Avantis, and the Quantum 225. Now, we've been working with a squelch of 10 on the Yamaha consoles, but that's because the LS9 and the O1B96 and the Allen and Heath are limited to that. They can't go any tighter, but the other consoles can go tighter. So here's a squelch of 16 on the Yamaha M7. Here's the MRX7. And here's the CL. Here's the X32, but remember the squelch is different, so in this case it's set to 10 even though it expresses itself as the equivalent of 16 on the Yamaha boards. And here's the Digico. The squelch is actually 20, which is its maximum, but that seems to match the best. Now on the MTX5 and MRX7 units, the EQ will allow you to have a squelch of 63, very, very tight. All right, well, that's about it for this test. So I have to say I'm very surprised by how similar everything is rather than how different anything is. I did not expect that going in. I figured at least the expensive stuff would be, very different than the cheap stuff on all levels. But certainly between brands, I expected there to be differences in the preamps. Everyone talks about how this or that console just has a sound. Even if you're not running a high channel count, you're not doing a bunch of like crazy EQ and compression, the different consoles just sound different. Well, I didn't really find that to be the case with these consoles, and that's it's not what I expected. Just looking at the Yamaha line, it's interesting how little change there's been through the decades to some of these core elements. I mean, they achieved linearity 2 decades ago or more and kind of just stuck with it, and that's been their claim, is that their consoles are very transparent. They don't have a sound. This, of course, is not counting like the Rivage series, which has the Silk preamps, which are this whole other thing. Obviously, I couldn't get a Rivage for this test. It just didn't work out. And then, of course, any other plugins you might use that emulate analog preamps or whatever, but putting all that aside, again, high degree of consistency and linearity across all of these products. Very surprised by that. So if I had to critique these consoles, I would run to the compression. I felt like that's where the biggest difference was. And I have to say I did not like the Digico compression. It seemed to lack all transient response in almost kind of a weird way. And I felt like it added a lot of distortion, even at reasonable compressor settings that I would use all the time. I thought the Avantis compression sounded really good, but I did not like how it doesn't offer a 0 millisecond attack option. I would use that frequently. Also, 50 millisecond release time as a minimum is, I think, a little bit too much. I use a shorter release time quite often for percussion and other things. Now, the X32 says it goes to 0 millisecond attack, but it doesn't actually. It's like the Avantis. It still has an inherent transient response that you can't get rid of even if you wanted to, but otherwise, it sounds really clean. In the Yamaha world, I don't like how the MTX, the MRX, the TF, and the DM3 have some distortion at their 0 millisecond attack time, but I am glad that it clears up at 1 millisecond and above. I really like the sound of the M7, the LS9, even the O1V96, the CL, and the QL. They are probably the best for me. I think that given that they have a clean 0 millisecond attack time, they go down to 5 millisecond release time, they have 6 knee options. They're just really clean, really accurate. They just do what they say they're going to do. Now, obviously, there's a lot more consoles that we could test. I'm sure that people are going to point out all the things that I missed in this test. Maybe we should do a round 2. And if we do, I would like to get a device that samples at a much higher rate. I was surprised to find out that even when the consoles are clocked, there are slight differences in their output times because perhaps the CPUs run slightly differently. If you like this video and want to see more and similar content, then subscribe to our channel and let us know what you think in the comments.